Hello, my name is Paul Thomas Edward Cusick. I'm an engineer by education, but I do research in just about every area that universities teach in. This particular talk is on nervous disorders, and it's divided into three parts. Part one is antipsychotics and diabetes. Part two is sugar and E. coli, diseases of the nervous system. And part three is on free radical oxygen. So in this first part, we consider the metabolism of excess sugar and associated excess thirst, known to be a side effect of antipsychotics such as olanzapine. We see from the mole balance equations in chemistry that other illnesses result, such as Parkinson's and Alzheimer's disease. The goal is to avoid diabetes in patients taking antipsychotics. Sugar intake should be controlled in these patients. Another side effect from the antipsychotic is weight gain, likely from excess sugar. So one patient is taking an antipsychotic, olanzapine, an anti-bipolar, clonazepam, and an antidepressant, citalopram, and Ativan for panic attacks. His side effects include Parkinson's symptoms, PD, short-term memory loss, AD, Alzheimer's disease, and excessive thirst and craving for granulated sugar, as well as sexual dysfunction. We concentrate on the thirst and the sugar cravings in this paper. So we have the stress hormone cortisol added to hydrogen peroxide, which yields sugar, and sugar yields C27H34O13, which is named fraxiresinol ioglucoside. A glucoside yields sugar upon hydrolysis, so when we add the excess thirst, we get sugar craving satisfaction. This is the metabolism of diabetes. Note that the chemistry will be shown below. Sulfuric acid as a dielectric changes the capacitance of the nervous system, which may lead to all nervous system illnesses. This would explain why we see symptoms of Alzheimer's disease and Parkinson's, twitches, and sexual dysfunction in people who take antipsychotics. So here are some chemical equations. There's 4 of them. And just run through them quickly. The GABA plus exhalation of CO2 yields cortisol and free radical oxygen, and the neurotransmitter NO minus plus acid. And then we have H2SO4 yields neurotransmitter plus radical plus sulfuric acid, which is a dielectric. And then we have cortisol, which results from stress, plus the toxin, and it leads to cortisol, free radical, oxygen plus sugar, which yields a glucoside. Conclusion. So for this part one, our conclusion is the excess sugar leads to diabetes. It also leads to excess cortisol, the stress hormone, and free radical oxygen, H2O2. These lead to other mental illnesses and perhaps Parkinson's and depression and Alzheimer's disease. Other side effects of antipsychotics include craving calcium, lettuce, and dairy products, and vitamin D, fortified orange juice. Orange juice also satisfies the fructose cravings. To avoid diabetes, these patients with mental illness should monitor their sugar intake. Another symptom of antipsychotics is weight gain, probably also due to excess granular sugar intake. To avoid diabetes, patients with mental illness should monitor their sugar intake. Another symptom of antipsychotic is weight gain, as we've said, and probably due to the excess sugar. So part 2 is sugar and E. coli, diseases of the nervous system. So here we have a diagram that I produced, and it shows it's color-coded. It's a little bit confusing when you first look at it, but if you study the various colors of the lines, you can see that we go from the gut and serotonin to dopamine over to adenine and melatonin, caffeine, goes to acetylcholine, and acetylcholine we have Alzheimer's and glutamic acid, which yields ALS, and from the caffeine we also have schizophrenia, and from the adenine we have Parkinson's, which leads to schizophrenia. The H2O2 hydrogen peroxide leads to Alzheimer's disease and cancer, and the symbol there shows that people with Alzheimer's don't get cancer. And the acetylcholine and the HSV, herpes simplex virus 1, yields Alzheimer's and cancer, and then sexually transmitted diseases lead to schizophrenia and Alzheimer's. So it's a complex diagram, but if you study it, you might be able to glean something from it. So in summary, low dopamine leads to Parkinson's disease. Serotonin regulates dopamine. Melatonin leads to a small pineal gland, which is a sign of schizophrenia. Pineal glands in the brain. Patients with schizophrenia have high dopamine, whereas those with Parkinson's have low dopamine. Caffeine and acetylcholine lead to high glutamic acid, which leads to ALS. Patients with ALS sometimes have frontal lobe Alzheimer's disease. Melatonin and caffeine damage the adenine, which leads to genetic schizophrenia. High iron and high sodium chloride lead to schizophrenia. Oral microbiology, sexually transmitted diseases plus iron and chlorine leads to eye trouble and Alzheimer's disease. Serotonin is involved in memory, thus Alzheimer's disease. Hydrogen peroxide leads to cancer, and acetylcholine and hydrogen peroxide lead to schizophrenia and Alzheimer's disease. So in this conclusion for this part 2, we see that when we consider these various diseases of the nervous system together chemically, we yield 2 volatile, highly reactive compounds. Combine these with stress and excess sugar, and disease results. These compounds could be the underlying causes of these nervous disorders. So part 3 is free radical oxygen and diseases of the nervous system. So in this part 3, we show that free radical oxygen is the root cause of mental disorders. Psychoactive drugs seem to absorb the free radical oxygen, thus leading to reduced symptoms of mental illness. Understanding the root cause of mental disorders could lead to a permanent cure. So in this talk we show that free radical oxygen derives from the toxin hydrogen peroxide, which results in mental disorders. In fact, it may be responsible for most mental disorders and diseases. We provide the chemical equations for one case of schizophrenia. For this patient, it began with binge drinking and alcohol consumption, which led to depression. Depression led to the prescription of an antidepressant Prozac. Natural methods of increasing serotonin, such as sunflower seeds, which have tryptophan, which produce serotonin. It's a precursor to serotonin. To escape a melancholic personality led to schizophrenia. The patient was poisoned with LSD twice, which may be also a cause of schizophrenia. Risperidone was prescribed and olanzapine were used to treat the psychoses. After decades of antipsychotics, panic attacks resulted, which were treated with clonazepam and citalopram. The patient was hospitalized in a psychiatric ward on 3 occasions over 20 years for a total of 5 months in the hospital. I think schizophrenia is actually the highest cost illness there is out of all the illnesses, because the length of time spent in the hospital and the frequency. So the patient was prescribed a second-generation antipsychotic, an antibipolar, and an SSRI, select serotonin reuptake inhibitor, antidepressant, and a panic attack pill. So there's the chemistry And I'm not going to go through all those equations, but well, anyway, we have GABA and dopamine, serotonin, and oxygen, which leads to cortisol, the stress hormone and neurotransmitter, plus an acid. Tryptophan yields serotonin plus a neurotransmitter plus free radical oxygen. LSD plus the oxygen yields serotonin plus a neurotransmitter plus acid plus alcohol. LSD plus hydrogen peroxide leads to cortisol, stress. Mood stabilizers plus free radical oxygen leads to lithium oxide. You can review these in your own time in the papers which are referenced at the end of the talk. So one researcher has drugs referred to as mood stabilizers, including lithium, have not been shown to be superior to other sources of sedatives in people diagnosed with manic depressive or bipolar. Several studies of people with psychosis or schizophrenia show that some other sedative drugs have similar effects to antipsychotics in the short term. There is no convincing evidence that any type of psychiatric drug works in a disease-centered way. So I'm not a nutritionist, but I hypothesize that a diet high in calcium and vitamin D would absorb the free radical oxygen into CaCO3. When we are under stress, we forget to breathe. CO2 builds up in the blood because we're not exhaling it. CaCO3, calcium carbonate, is harmless to the body. It is used as a placebo, in fact. I know the patient craved milk, ice cream, and lettuce, all sources of calcium. Mental diseases such as schizophrenia, gender dysphoria, autism, bipolar are spectrum-based. Therefore, we can assume there's an imbalance in the neurochemistry of the patient. This imbalance can be modeled by a teeter-totter, where the balance is in the middle. The forces at either end represent the mass or force of the neurotransmitters, as you shall see in the next slide, the diagram. There it is, neurochemical balance drum, two-dimensional drum, and just basic mechanics. So there's a bunch of math associated with this this particular paper. It's called, I called it AT math, for astrotheology math, but it's rather dry to run through it, but so I decided to take it out of the talk. But anyway, the bottom line is that there's what they call the golden mean parabola, which is the equation that governs the human mind, and it's t squared minus t minus 1 equals 0, where t is time. And there's a lot to astrotheology math, but all you really need to remember is that golden mean equation, t squared minus t minus 1 equals 0. So the mass of free radical oxygen is 15.998 or 16, and if we take the mass divided by 16, we have 13, and we plug 13 into a modified form of that golden mean parabola, t equals e squared plus e minus 2. We result in 179.12, which is 180 degrees, which is equal to pi, which is the fulcrum or the balancing point of that teeter-totter. So the mass is equal to ln t, we know from astrotheology. If we set it equal to 180, then t is equal to 0.618, which is the golden mean parabola root, and 1 over m is equal to 1.618, which is the other root of that golden mean parabola. So post-traumatic stress disorder and panic attacks are treated with benzodiazepines. The neurotransmitter is active in all parts of the brain and is in the body's main inhibitory transmitter. So post-traumatic stress disorder and panic attacks are from the anxiety caused by the anticipation of a stressful event that may never come. This leads to anxiety, and I argue that all mental disorders stem from anxiety. I continue that theme here except that it is stress hormone cortisol that leads to mental illness. So the chemistry is GABA plus exhalation yields cortisol plus a free radical, oxygen, the H2O2, plus a neurotransmitter, NO minus, plus acid, H plus. So there we have a diagram, our second diagram. This one's on the synaptic gap between neurons. And if we have H2SO4, it acts as a dielectric. And if we take each neuron as a capacitor, and the charge builds up and jumps across the synaptic cleft, then H2SO4 is an important chemical in neuroscience. So sulfuric acid acts as a dielectric in mental illness. And there's a long chemical equation which shows that a radical plus a neurotransmitter yields sulfuric acid dielectric. And exhaling CO2 plus acid yields cortisol, stress. And if we take H2SO4, the sulfuric acid dielectric constant is K equal to 101. K is the permittivity of a chemical versus the permittivity of free space. And we end up with Cm equal to 32.15, which we carry over to the next slide. We plug that into our golden mean parabola, and we end up with 1.0004. So, we use the equation from physics, we end up with the density, which is 4 over pi, which is also from astrotheology mathematics, which I'm not going to go into in this talk. If you're really interested in AT math, I must have written over 100 papers that have AT math in the title, or also called astrotheology. There's a bunch of papers on that too, if you're interested in the mathematics behind all this. And the mathematics is also covered in these 3 papers. So if you refer to the papers, which I'll refer to, you can see the AT math if you're interested. So the conclusion is that free radical oxygen provided from hydrogen peroxide seems to be the culprit in all mental disorders. So H2O2 is a very important chemical. And that ends the talk. I'll just show you some references. Too many to read. They're the papers I've written, and I refer to them so people can trace from paper to paper.